Hey there guys, this is Adamant Life and we are back with another episode of the mechanical deck box build, design, etc. Pardon me, I was just eating. So, obviously it has been 10 days since my last live stream, which is not ideal. I'm not going to provide explicit excuses at this point, because making excuses is not really useful. I will simply say that everything that was on fire is no longer on fire, and everything that could be fixed is as fixed as going to be. And I'm pretty optimistic that going forward in the future, it's not going to take me this long to put out videos. And by videos, I mean I finally got to upload the first video of I Made a Thing, which was the cartridge screwdriver holder. So if you haven't watched that already, by all means, that should be up on the channel right now. Go watch it when you have the chance. Obviously after the live stream. And if you're catching this in the future, then by all means pause the video right now and come back to this video after you're done watching the other one. So that catches you up on everything in between when I went on vacation, quote unquote, which was actually a work trip, but I'm calling it vacation, and this moment now. So last we were here, we have this mechanical deck box. Originally I wasn't going to make it. I recall being in between, a puzzle box and a mechanical deck box, and it's turning into more of a puzzle box. As I recall, this piece right here slides, which triggers this piece. This piece, if I recall correctly, is a latch. Let's see. Yeah, spin top. So I had a spin top over here, which gets unlocked by this back piece, outer case, back wall. Yeah, okay, so I haven't done the latch yet on that part, but the plan is to you slide this forward, which rotates this up. That releases a latch, which allows this side piece to start spinning, and this side piece spinning opens up this front cover and the lid. I believe that's how I was going about it. So, let's go ahead and get on to completing this thing, then, now that we know what we're doing. Excuse me just a second, I'm gonna grab a meatball. Okay. So, let's go ahead and integrate that latch then, and assuming that we'll make this so that this, well, yeah, probably the simplest thing to do is to have the latch more or less center here, and for there to be a cutout on this spin edge so that the latch rotates this way, and then that gets out of the way of the spin ledge, and the spin edge can't spin forward or backwards because it runs into it in either direction. So let's go ahead and do that. This is the outer case back wall. Let's highlight that, and I will go ahead and actually, I'm thinking we probably have a construction somewhere around here. Let's see, inner case, construction, back wall. Okay, maybe we don't have a construction for the left wall yet. Spin top? Nope. Alright, let's hop into the spin top then. Spin top actually appears to be overlapping the deck box, if I'm looking at this correctly. The deck box is blue part, yeah, that's definitely overlapping. So let's pull you out first. Modify, align, deck. Get that. I think we have that wall connected. Actually, I can do this. Get rid of the inner case, and now we definitely have that one connected. Toss the inner case back in. Turn the, where is it? Spin top off. and go there. Alright, so now that is outside of the inner case. Okay. And now we just need to add and left side wall to the inner case. That's what we're going to do. So let's hop over here, construction, capture position. Face, 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 that face. Alright, now we have our left of inner case. Pardon me, I gulped those hot meatballs down. And we hop back to the spin top. Do we hop back to the spin top, or do we hop to the outer case? I think we hop to the outer case and do that way. So if I look at this, the thickness here, whoops, inspect, thickness is 5mm. I'm surprised we were that thick on here. That's pretty bulky. Yeah, that should probably be thinner. So let's spin top. Do I have a wall thickness variable yet? No. Alright, so we'll just call it 3mm. Alright, now that's lining up with the back case, which is what I was expecting. Back wall. And now we can go on the inside of the back wall or the outside of the inner case. Back of the inner case. And we will take a projection here. Okay. Whoops. Nope, not okay. I hit finish instead of project. Okay. And now let's turn this stuff off. Turn that off, turn that off, turn those off, and turn the spin top off. Okay, look at it. I don't need the sketch grid. Here we go. And again, I'm just going to toss this midpoint. Actually, I'm not even sure I'm on the right plane here. Yeah, see, I went through that left wall in there, the left construction wall, and then I didn't even use it because I was stupid, basically. So, left inner case. This is the way I should have done it. Here, project that, and then turn everything off. And now we can throw this little tab in here. And how do I want to do this? Well, let's start by turning this into construction lines. What shape do we want this to be? Triangle shape's probably fine. Midpoint, like that, to there. Overall, we'll make this, it could be a little chunky. Let's make it 10 by 10. And then we'll make this midpoint on here. And then all we gotta do is extrude that out. Okay. And we grab the spin top, spin top. Project, or use the left inside case, and now project. Actually, so this side, let's think. So right now, as I have this designed, it is not the full length. We probably want to fix that first, unless it's not necessary. It may not be necessary. Let's think about this. Yeah, let's fix it first. So, turn the body back on. Whoops, we're not looking. There we go. And let's extrude that out to there. Not the prettiest way of handling this, but it will work. Alright, now we can go forward, hop back into our, project that face. And then we will need, because this will be rotating back up like this, it will need to sweep, and this is in a circle, in an arc rather. So let's grab the arc of the Covenant. Center point arc? Nope, that's not a center point arc. Do I have that on my quick? No, I do not have arcs on the quick axis. Alright, and I'm having a little difficulty seeing this stuff, so let's start turning stuff off again. Turn the whole entire outer case off, turn that body off. Okay, and that's why I didn't have a center line there, which is what I was kind of curious about, because it's just a face, it doesn't have a center line. So that now can go center lined on that. And now we have the full sweep. So I will just throw some extra lines in here. Why are you... Oh, because you are not on that face. And now we can extrude that out, cut it out to object. Actually, all. It really should be all. Okay. So let's hop back up to the deck box, turn some stuff back on. Outer case, and let's rotate. Which rotation are you? Find in. Whoops! Give me a right click. Right click. Find in browser. There it is. Joints. Edit joints. What are you between? Okay, you are the spin top rotation. What I am looking for is this rotation. Whoops, this rotation here. So let's hop back up to the outer case. And as built, that will be rotating around the inner case, and it will be rotating around. Whoops, what did you just click? Let's turn the inner case off for just a second so that I can get the center of this. Okay. Turn the inner case back on, just to make sure that everything's actually rotating the way we think it is. And now we throw the motion link back in here. I believe I had this motion link in here before, and it broke if I recall correctly. So, let us go to the top part, throw in before this motion link some limits. Edit joint limit, minimum, maximum, and is this positive? This is positive. Couple things here. One, that appears to be clipping through the edge, which we'll have to fix. Two, this 90 degrees should be our range of limit. I'm realizing that that is causing interference over here, which is probably why. Okay. This is fine. We can figure this out. So let's start driving this guy again and just make sure. Oh, right. Because it's spinning up here on top. It's not spinning on center. Okay. This is going to change some things. Let's see. In that case, I may not even do that actual cut on the wheel, and I may just offset it. That's how we may fix this cutout. And then otherwise, for the rest of this, let's think about this. So we're sliding this forward. Well, let me demonstrate over here. We're sliding this forward, and this is going up. This is running into that right now. We could do a couple things, right? We could put more of a gap back here. I don't particularly want to do that, so which means that we're more looking at cutting the inner case. Now the inner case, let's see, probably, I'm assuming 45 degrees is the most intersection. I could be wrong though. So at the lowest point, at 40-ish degrees, it looks like we have the most on the lowest point. Okay. Let's revert that and let us fix this for the time being. So we're going to get rid of this arc rather. I'm going to throw that back in. Throw that in. Finish. And then that can just be, whoops, not that. That can just be, turn that off, turn that off, turn that off. Okay, there we go. Spin top, body back on, all, flip, flip. Okay. And then we'll back up here, spin top, and we're just gonna offset that. Whoops. We're just gonna offset that for the time being. I guess that's not gonna necessarily work. Push pull. Fillet is not what I want. There we go. Let's just go a full millimeter to be safe. And let's come back up here. Or let's go over to the inner case. So, where's my deck right now? My deck is right there. It's pushed right up against that, which means that the deck, actually the deck is larger than. I'm not sure how that happened. So let's hop down here. Maybe not there, maybe here. This is the deck, isn't it? Huh. How did I accidentally nudge something? That's what that looks like. That looks like I accidentally nudged something at some point. I don't see it though. This is the only... Oh. Yes, it does look like I nudged the deck box right there. Alright. So let's delete that. Alright, there we go. So now the deck box is in there. However, now we're going to have to make this a bit wider. So where are you located? Inner case. Let's hop here. That's already created before that point. So we hop back up here. And this is what happens when you don't create your components first. You gotta go find it. Alright, so we're gonna need a little bit of extra space back here so we don't crush the and actually the way I'm gonna do that instead, I know I'm hopping around a little bit here, but I'm gonna thicken up the back wall instead. So we're gonna go to 5 millimeters instead. And then we're gonna hop up here, make sure everything is still kosher. Looks like everything's still kosher. Alright. And now I'm gonna hop in here. Well, let's visually confirm this one first. Go one more to get that. And does that... Cool, okay, so that clipping, we're not actually hitting the deck now, which is the most important part. Not hitting the deck is the most important part. Now that we thickened up that wall, now we can just cut that back wall. And if we look at how we're printing right now, we can print either in this orientation with the bottom being here, or we can print in this orientation. Neither of those have overhangs, and therefore we're still safe. This way, if we chamfer the back of the inner case here in order to compensate for the fact that we're going to be clipping, with that we're going to be encouraged to print up and down, but it's something that we're going to want to keep in mind as we're designing, to make sure that since we're printing in 3D printing rather yeah, printing in 3D, since we're 3D printing, we want to make sure that we're not making any design decisions, or at least we're compensating for our design decisions and making sure not to introduce problems with printing that may require overhangs or whatnot. So I just did a 90-degree chamfer here. We're gonna see whether or not that actually works. So let's rotate this joint, turn the outer case back on, and let's do this. I'm gonna do, where is it at? Interference, capture positions, doink doink. Okay, so it is clipping there, and I'm gonna go ahead and rotate this up to, yeah, that's probably fine. Actually, visually, that looks like we got enough of a gap here. So let's go back to 45. Inspect, interference, capture positions, boink boink. That, no interference. Okay, so we're going to change this chamfer angle. Not equal distance. 2 distances. I think we can do this with 2 distances. Yeah, we can. Okay. Do that. We'll set this back to 20 degrees, which is where we had some interference. Capture position. Interference. And we're still clipping that. So we'll go ahead and modify that some more. Chamfer. I'm going to just hop all the way up to 7. Capture position. Interference. Doink and doink. Still there. So yeah, this slope is a lot more than I thought it was. It's a good thing that we're getting this taken care of before I actually print it. No interference. Alright, cool. And the next thing I'm going to do is I'm actually going to go ahead and visually confirm this rather than, because I'm pretty confident at this point. So rather than using the interference tool, I'm going to go ahead and throw the section analysis on and watch it. Let's hop here. Whoops. Actually, that looks like that might be touching there, which is annoying. Let's go up to 90. Looks like it clears it above 90, above 50, yeah. So let's go back down to 5, okay. And let's capture position and run that interference again. Okay, yeah, it is. So we fixed that. Call it 11. Interference. Whoops, not those two. Those two. Interference, no interferences. Alright, so I'm guessing at this point that we're clear there. Not ideal, but this is the way we have it being designed right now, so I'm not going to complain about it. I believe both of those are unnecessary, those positionings that we saw there. I don't think I was using either of those. I think those were both positionings of the rotation here. Now the last question to ask is, what is our thickness here? Because the printer doesn't particularly like this thing Alright, it's 1 millimeter. Printer can handle 1 millimeter. Once you get below 1 millimeter, in my experience, it's pretty ugly, but 1 millimeter should be alright. At least on an FDM printer. Alright, then we have the motion link that we were enabling, which led us to this part. And it's not working, which kind of sounds familiar. I wonder if we had that problem last time. Okay. Let's turn stuff back on so that we can see it. Where is right side wall? There we go. Huh. So this is driving the other one, but not that way. Interesting. It's one of those things. This is a highly unnecessary modification here, but we're going to do it anyway. All right, cool. Let's take a look here. And that's still clipping on this side, it looks like. So let's back ourselves up. Go to the spin top. And rather than offset this, I'm going to chamfer this edge. Like we did with the other one. And the reason I'm doing this, I've changed my mind to do this, is that this will still lock in place. Let's hop up here so we can actually see what I'm talking about. Huh. Why you do that? That is fascinating. There are a number of fascinating things right here. Somehow the spin top is back inside. Oh, the spin top was one of the... Okay. That would explain that one. Okay. And this chamfer, I clicked the wrong thing. So that explains those two questions. So let's get you, modify, align, turn these guys off, intercase, turn that on, turn the intercase back on, turn the spin top off. There. Okay. Huh. What happened there? Okay, it's aligned. I just don't see... Where's the positioning for it? Where'd you go? Alright, whichever. It's where it's supposed to be. And now let's hop back in here and chamfer the edge. No? Okay. It's not on my timeline. Oh, okay. Oh boy. Spin top. Modify. Align. Intercase. We'll get there. We are going to get there eventually. It may take a million years, but we are going to get this back to a usable state. Capture position. Okay. Turn that back on. Okay. It appears to be in the correct position now. Now we can turn the back wall back off and go back to chamfering this and do 7 millimeters to try to be safe. Back wall. Let's rotate. Actually, let's hop up to here and rotate. Alright, that does appear to be clearing. And actually, the interesting thing is that That appears to be clearing on a much lower level than I thought it would. So let's 5. Rotate. Nah, okay, there it's clipping, so... Okay, to get rid of that clipping, because we don't really need all this, I'm going to do a combination of the two things that we've done so far. So I'm going to drop that back down to 3, for the time being at any rate. And then I'm going to go back and offset this face. .5, okay. And let's see what that looks like. Turn the back wall back on. This does, so what I was trying to avoid, which is why I didn't have this face offset in the first place, was I was trying to avoid slop. So you can see, in theory, well, it shouldn't really in theory, so I guess it's not that big of a deal. In theory, if it could move forward or backwards, the spin top or the back wall, in theory, then you'd have a little bit of slop because this isn't flush here. But the spin top shouldn't be able to move backwards because these edges right here are contacting, so it can't move backwards. And this back wall is not going to be able to move anyway. So it was probably an unnecessary worry of mine. And that does look like that is going to clear the whole way now. So that is where we're at. Cool. The next step will be throwing a pivot section here for the spin top. So let's do that. That way it's connected to the inner wall. Inner case, spin top. How do I want to do this? Yeah, okay. Come in here, left-hand wall. Use that. Project. Just the inner case, not the spin top. Okay. Do that. Turn a bunch of stuff off. Turn that off. Throw our cross line in here. Throw a circle in there. Call that 10mm. Make that centered. And make this a construction line. And then we can extrude. And actually we're going to extrude on the inner case. Bodies. Distance 2. Spin top. Okay, join. And then we will combine that and that. And we will be cutting and keeping tools. Oh, I did that the wrong direction. It should be, whoops, excuse me. Should be spin top, combine that and that, keep tools. All right, there we go. And I'll offset this for 3D printing, 0.05. All right, we're getting there. Only half an hour in and we're pretty close to being done, I think. Well, kind of. It really depends on how well this next part goes, which is removing the top from the deck box. So the idea here is that this spins and that in turn moves the lid off of the deck box. Now, originally, I was thinking about having this be segmented right here. Let me really quick do some moving around. Oh, that's right. I do not have my desk camera on me at the moment for reasons. But let's see. Let me do this. Let me just throw you to a blank screen really quick. Maybe, no. Not like that. Where is my actual... let's do this. There you go. You're on a black screen really quick. Well, I pull up the deck box again. Thingiverse. Thingiverse. Deck box. I should probably make a waiting screen. That would be useful. All right. We have this back in here. So let's get you guys back over here. All right. So you see how this is hinged like this? I was thinking about doing something like this for the top here. So if we swap back to Fusion. Whoops, not that. Ignore that. If we hop back to Fusion, you can imagine the hinge being on this corner, this corner, this corner, and then another hinge back here. And this, I was going to rotate this corner up, which drags the front lid open, and then when it gets to up to this corner, we have basically a TP type shape here. That was my original intention. Instead, we're actually probably going to go spin the opposite direction since we're stuck over here. Now that's going to mean a couple of things. One, this spin top. Let me go ahead and, so that you can visualize this, bring this lid all the way up. Which one is that one? That's that one. So we're up at 90 degrees, right? And this is the reason why I can't have the hinge go this way in theory. I mean, technically speaking, I still can. I could put the hinge here and then have it hinge up there, which is not a bad idea. We could do that. But the other ideal I was thinking was after we get to this point, what I was thinking about was turning it this way and having this spin top spin down. So we're taking just this front lid and rotating it downwards, but this is going to be in the way back here, so that's not actually going to work. So let's go back to that second idea that I had, well, the third idea that I had, which is that we will put a hinge across right here and a hinge here, and then this will drag up. The rotation here will drag the hinge up. Yeah, I'm just thinking over this in my head. And that should work. Now, the only thing that's going to be a bit annoying is you see how we have a solid wall here. In order for this to complete this spin, we do have this spin here. So in order to get all the way open, which is 90 degrees here, we're going to end up losing this corner. This corner right here, in case you're not seeing that. Oh, actually, that hinge is off at the moment, so let me delete this and re-add it to the hole that we just created. As built joint, boink and boink. Turn the inner case off and do that. Okay, and while we're here, we'll edit joint limits. Minimum, maximum, minus 90 degrees. Okay, so, oh wait, I thought I just spun up the, okay, on the old joint, minus 90 degrees with the other direction, in my defense. So this is 0 and that's 90 degrees. Okay. So, yeah, as you can see, we're gonna, actually, that's not even gonna work. So this ledge is gonna have to be lower. So the problem I'm introducing here is that this edge, which if we roll back here, actually no. Okay, so that edge doesn't necessarily have to be the edge that moves the, we can have the front lid connected on this edge, so that's not going to be a problem, but we will need to cut this right here. And I'm just checking if that is something close to, because we're centered on a circle, that may be a straight up arc this time, as opposed to the funky shape that we had on the other one, because it's off-centered, because the pivot point is in the corner. This one we maybe have a much easier time drawing this arc. Looks like maybe, I don't know, we'll find out as we develop this. But obviously we have a hole here on the side and a hole on here, so I'm going to have to figure out something else to attach to this side, which may or may not look weird, but that's just something else that's on my mind and the reason for this whole entire tangent right now. So that's where we're at, to keep you in line with my thought process. So which position am I capturing right now? I'm hitting Control Z and I have no idea what I'm redoing. Okay, let's just capture position and then, oh, okay, that's the position I'm capturing. Okay, cool. I am happy with that. That is fine. That can stay there for the time being. And now we will have to hop back in here to the spin top and get to cutting. So we're going to be cutting this corner, just so that we're on the same page, and I will go ahead and continue to use the inner box's left inner case to cut this on. Let's do that. And let us, well, that's not going to work. It's going to have to be an arc centered somewhere over here. Let me, it's one of those things, if I was doing this offline, I might take a couple minutes to attempt to do some math. I'm not convinced that I know what math I'm doing here, which is why I'm not doing it on stream. But in theory, if this is rotating on center, then I think the distance, yeah, I think I should be able to mathematically figure out the distance that this is going to be from, where's the back wall? There's the back wall. From there to the impact point. I'm pretty sure that I should be able to figure that one out, but yeah, all right. Well, let's look at it for a second, right? So the distance there is the distance from the back wall to the top. This is from the back wall to the top is the distance from the back wall to there. Yeah, I don't feel like doing math on stream. Math on stream tends to go wrong, as is evident by the gear ratios that I totally screwed up last on the turntable project. So I am going to eyeball this for the time being, and I will fix it later. So let's call that 50, and let's call that 50. That probably shouldn't be 50, but the other way to do this would be to do it the other direction. I'm just wanting to make it square, so 21.5, 21.5. Okay. Control Z, Control Y, that. Distance all, okay. And let's rotate this now. See where we're at. Again, one of these things I'd like to do more precisely, but I'm not confident at the moment that I'm going to get the math right. So I will come back and fix it myself later. Right now we're just trying to get through this stream. Now the next problem that I'm realizing is that when we rotate this back, we're down below the wall here. So we're for the spin top probably is going to be shorter, and this matters less because in the future we're going to have this covered up. So it was the full length of the wall because I was assuming it may be visible on the outside, but since at this point we've determined that this needs to be covered up by something else so that you can't see it because it's super modified in order to fit around the pieces, for that reason we will go back and fix it. So let's find the spin top. And why are you longer than you look like you should be? Let's roll here. Autobots roll out. Oh, right. I added this one. So let's delete that one. Yeah, it really shouldn't screw me up, right? I don't think it screws anything up. Where's my errors? Yeah, I don't see any errors. I think I'm alright. And let's rotate there. Alright. So, basically, what we want to do here, let's hop back into spin top and go back to this original one. Rather than that, one of these, this one is 60 and this one is 66. So we actually want this back wall to be 60 from the front. It theoretically could be... Whoops, let's fix that really quick because I just spammed the construction line button. It theoretically could be centered on here, but it's not necessary. And it looks like we're not actually connected there to complete this. There we go. Finish. As opposed to Norwegian. Are you not? Huh. Where is my profiles? Show profiles. Yeah, that's profile. There we go. Much better. When your show profiles button randomly goes off. Okay, and that now has to be larger. So we will hop back over to the back wall and draw this back in, and instead of that being 10, we're going to go ahead and project that. Okay. And we're going to say that this is 5 millimeters in. And we can do this. We can make this just generically equal to that. That we maintain our triangle shape. And let's hop back to the spin box. Spin top, and we're gonna have to re-examine this to make sure that we're still clearing since we moved it, and we are. Cool. Alright, and now we do have an issue because now this spin top is off of the back wall. It's no longer touching the back wall, which means that the spin top can turn. So, that may be a problem we leave for later. Otherwise, that is now... Whoops, stop it. Stop it! That is now clearing. Okay. And we probably want to mirror that across the center line. And do the bottom, and the reason we'd be doing that is because you see how this is scraping, so you can't actually spin this while it's on the ground. Now that may not be a problem. It may be one of these things where you just gotta have to pick it up and clear it. So actually we may not. Yeah, I'm gonna skip clearing mirroring it for right now. But we do have to do this part right here, which is connect the front to the case. So let us think about this for just a second. So what I'm thinking about is how the lid will connect right here, because if we look at this, everything is in line, and the inner case is again not in the correct position. So we're gonna have to fix that. Actually, it's the deck box that moved. When did the deck box move? How does that keep on happening? Get back there. And everything broke again. Oh, is that what happened? Oh, I know what happened. Alright. I think I know what happened at any rate. Let's slide you back down there. I think the reason it keeps on moving is because I'm accidentally clicking it. When I... Alright, that was clearly not the correct thing to do. When I moved the... when I was moving the spin top over, I believe I was actually getting it in the selection, which was the problem. So anyway, back to this lid, this hinging lid. So right now the outer wall is actually, the inner wall rather, is actually going to have to go up, which is a complication. And it needs to go up in order for us to have something to attach the folding lid onto. It's not as big of a deal. It's just something that we're going to have to figure out where exactly to do that at. And it's going to obviously influence this because, let's look at the outer case by itself. These are the same size as the inner case. That's what they're sized off of. And if we're going to change the inner case size, then we're going to need to change the back wall and the right wall to match that, to cover it up. So that is a complication. It shouldn't be that big of a deal, but it is something we're gonna have to do. So let's rotate back over here. The question is where to do it at. What point in the timeline is the most convenient point? And I'm gonna go ahead and back up a good amount. And I wasn't too concerned about the random cars that you guys might be hearing, but it sounds like somebody's starting to weed whack, so give me a second. Alright, close my window. And I just realized my fan's still on, so I don't know if you guys have been hearing that one. But the fan is now off too. One of those things early on, I listened back to one of my early episodes and the printer was running and it doesn't sound like much to me, but listening to the printer on the video, I realized just how freaking loud it is, so I try to keep things as quiet as possible for this. Alright, which is why I just turned off the fan and closed the window. Where do we start? This created the spin top. This spin top doesn't actually need to get bigger, so I'm thinking about leaving it right there. This guy, however, let's make sure that we know what this guy is. I'm assuming this is the inner wall. Who are you? Who are you? You're just a body. Okay, yeah, you are the inner case. So let us go ahead and make you a little bit larger. Do that. Not do that. Do that. And do that. And now the question is, how are we connecting this lid in order to determine how much larger this needs to be? So if we it's one of these things I'd actually like to use pins instead of the original deck box used brad nails, I believe is what they suggested. I ended up using paper clips in mine just because I didn't have brad nails. It's one of these things where I really don't want to go down to 2mm. I could do 2.5mm screws, but that's still a little bit big, a little bit large. And I'd like to keep this as small as possible. The question is if I make this 4mm right here, and we do 2.5, that leaves 1.5 millimeters around it, which is 0.75, which is a little thin on the wall and doesn't compensate for the head of the screw, which is a little bit of a problem. Actually, let me double check that statement I just made. Where's my 2.5s? 2.5s. Alright. Head on these 2.5 millimeters. Grab one of the larger ones so that they're easier to hold. Open the baggie. Try to open the baggie but have fat fingers. Try not to destroy the baggie. Good bunch of men. Come on. Why are you being difficult today? Alright, we're trying a different bag. There we go. Bag opened. And the head on a 2.5 millimeter button head is about 5 millimeters. Yeah. So 5 millimeters is larger than 4 millimeters, which means that the head's going to be sticking out of this 4 millimeters if we do that, which is a bit of a problem. Again, I'd like to use some kind of pins in this instead, just because they're so much smaller and they're unlikely to fall out. The only issue is that I don't necessarily if I said, okay, this project uses 2.5 millimeter screws, then it's one of those things. It's 2.5 millimeter screws are easy enough to use in other projects, so it's not a huge investment for anybody that wants to make one of these. But if I said, use 2 millimeter pins, it's like, why the heck are you ever going to use another 2 millimeter pin? I have 1 millimeter music wire. In theory, if this was just for me, I could just grab some of this music wire and use the 1 millimeter music wire. But yeah, this is annoying. Okay. So the conclusion to all this ranting is, if I make this 5, the head of the screw is just barely poking through, which is not that big of a deal. Yeah, I guess that's just where we're at. Yeah, alright, that's just where we're at. This is just going to end up being 5 millimeters. And next question. No, I don't need to modify the outer case on this sketch profile just yet. Back up a little bit. Make these construction lines. Finish. Alright, there we go. And this is going to influence our other stuff a little bit here. What are you? You are the spin top, and what are you? You are the inner case. Okay, so this is back to before the spin top, actually. Alright, let's delete that and project that instead. Okay. Finish. And then you will be that profile instead. Okay. And you, what is your problem? You are missing lost projections, face, relink, that, okay. And we can leave this down low like this. Not really a problem. Okay. What's your problem? No, I said you can just go ahead and link that. Why? Why? Alright, let's turn these bodies off really quick. That's not the correct bodies. Turn these bodies off really quick. And see what we're looking at. Okay, is this a matter of sketch line being full? That might be it. Let's turn the spin top off because we don't need that. Oh no, that's going to have to do that. That is going to have to do that. Actually, yeah, alright, let's leave that on there. And then, let's try you again. Let's turn. What is. This is frustrating. Why is this doing this? You see how. Do I have extra sketches on? If I turn the sketch off. Okay, that is that. Turn the deck off. That may have been the problem. Okay. That may have been the problem. That I couldn't see the sketch and I was clicking the wrong thing because of that. No, that is. Why is that selecting? This is nuts. I only have one sketch. So why is it selecting the rectangle there instead of the full thing? Let's turn the bodies off. Yeah, it should just. Why? Alright, I am confuzzled. That's a profile right there. Why are you not? What profile are you selecting? It should not be selecting. Do you see this right here? Does that look anything like that profile? It does not, does it? Alright. We are backing up, deleting that. Yes, delete it. And trying this again. 5mm. Turn you back on. What in the world? What profile are you selecting? You're not selecting any profile. Okay. Am I going crazy here? Right? It can't be selecting the deck box. It wouldn't select the whole entire length. It was selecting the deck box. So, let's delete this profile altogether. Alright, we're not selecting anything now. That's good. That's what we expected. Alright, let's go to constructions. And yeah, I do not see a construction for the back of the deck box. Or actually, I take that back. I haven't actually looked for it yet. Backside of deck box. Let's do that. Okay. No biggie. We'll figure this one out. Alright. Turn the deck back off. Select that. Select that. Throw in this guy. Okie dokies. Cool. And I know I said that this profile selection didn't have to go all the way up to the top. And it really doesn't, so I'm not going to. So let's find the deck now and do that instead. All right. There we go. Cool. Align that. Align that. Align that. And we should be back to where we were. So 3mm walls. join. Oh. Herp-de-derp. Alright, back up. You. That and that. Finish. And let's try rejoining that. Join. Okay. There we go. Much better. I'm not sure what you were. Okay. You do not actually need to go all the way back, I don't think. Actually, yeah. You should go all the way back. So we'll go ahead and do that. Okay. And let's see what this is. Okay, this is the back wall, it looks like. So, this should be missing reference, right? Yeah. So that, I'm assuming, was there. Are you missing sketch profiles or, yeah, missing projections? No problems. You are fixable. Manage lost profiles. Face. Turn the sketch back off. And the face we were using. Oh, click, re-click. Okay. There we go. Finish. How we were looking. Everything looking right. I guess that's right. What was that? Oh, the dice chamber. Okay. Gotcha. And this is the outer case. And then we combine that with the gear, right? Yep. Okay. Everything's looking good so far. And that's red and green. Nice, nice. We do have this coming up, the slant, to make sure that we don't collide. Oh, and actually this one too. We have this problem as well. So let us move that pivot point up. That would be back here somewhere. Whoops, not redefine. Roll. Let's see. Okie dokies. Yeah, that one. Right, so we want that to also be 10 millimeters. I'm trying to think. So if this pivot point is here, then as it rotates around, actually, if we move this pivot point back or forwards is worse. Back is, sorry for the car, motorcycle, whatever that is. Let's see. Actually, it's almost 5 o'clock, so I'm actually going to need to start wrapping up here soon. If I move this back, it's just pivoting, it's not going to change anything because that's what it is. I would actually have to move the whole entire wall back, which I'm not going to do. So, as for this part here, if it has 10 from there to there, then that should be 10 from there to there. Or, if we move this in, rotate this up, then we want this one, we want the north-south one to be shorter than the east-west one. And again, this is going to be alright only because I'm going to come back here. Maybe not that one. Let's see. Why do we keep on flipping upside down? Do this, do this, do this. Okay, so I did not modify this to be any larger at this point, so we will go ahead and do that now. We'll go ahead and take that distance to object. There, join. And now when we come back up here, that pivot point will still be solid. Okay, cool. And we fast forward some more. Fast forward some more. This back wall should be higher. Which back wall is that? These aqua colors, for some reason it's got two aqua colors in here, so that's the outer case. And this is then the dice chamber. Okay. Okay, so the outer case we are going to want as high as... Do we really need it though? Yeah, I guess we do because we're going to be printing it. Yeah, so when this prints, so we're on the same page, this is a little bit of a problem, but I'm not going to complain about it just now. So let's look at this. So the way this obviously wants to be printed is like this. Because if we look right here, nothing is overhanging. Nothing here. These big walls, I should say. The big walls are not overhanging. That's why it kind of wants to be printed like this. The problem is that these teeth are overhanging, so these teeth are probably going to need supports. This one definitely, that one probably, these two probably not. These two are probably fine at these angles. It's a little bit of a problem, but it's what we're dealing with. The alternative here is to print it like this. Whoops, not like that. Like this. And let me rotate this way. Didn't mean to go that far that way. And let's get a corner view so that we can see this better. So printing like this, where this is the bottom, so that keeps all that fine. This then becomes a problem that needs overhangs, and we can't incorporate a chamfer into it like I would normally do. Normally, if I have a weird piece like this that needs to be printed here, I would go ahead and slope this down, but we can't because the rest of the deck box is in the way. So unfortunately, while I would prefer to print it this direction, actually there is a solution, and the solution is to actually cut this tab out and print this tab separately and glue it on, super glue it on, which is not totally unreasonable because we're saving all the material that we would need for the sports here. And if we rotate it back the other way, let's see. Let me do this. Yep, there we go. So if we, do that. So if we're printing like this, then the supports we're saving in the front here, we're saving some supports here that may make up for the fact that we have to print this separately and glue it in. So it's a trade-off. I'm not entirely sure it's necessary. I take it back. There is a third solution here, which is to not print this and instead use a screw here. Because all this is just a tab to hold the thing in place. We could actually turn this into a bolt, put the bolt through, cover it up with some cover piece on the backside so that user can't see it, or can't see it as well, not as obvious, and then use that as the pin to hold the whole entire contraption from rotating. That is definitely an option. Regardless, before I get off here, I do want to make sure that the rest of the design is updated for the higher lips. So let us go ahead and that doesn't look like it is. Let us rotate you back down. Let's turn the inner case on. Yeah, so this wall needs to be updated. Where do we make you? Alright, there we go. So this looks like this is a simple fix here. Just go parallel to that. Alright, that's updated. And then we don't need to update this spin top, I decided, because this spin top is going to be covered up. So that gets us wrapped up there, and we should be... It's funny, I said, you'll recall, like 15 minutes ago, 20, or no, actually it was at half an hour in, about half an hour in, I said, oh yeah, well, it should be done pretty quickly unless anything goes, wrong. And sure enough, we had to make some serious changes. So, oh, here's one thing that seems to be disappeared off the timeline, which is weird, which is that is no longer chamfered. Now the question is since we moved this pivot point, yeah, it looks like it's still interfering, so we do have to come back here and chamfer that again. Question is where did that chamfer happen originally? Fascinating question. Let's go ahead and fix it right now. This is our pivot point, right? Yeah, that's that pivot point. So we are fine. What alignment are you? You are... Okay, you're the alignment for the spin top and the deck box. So before we do that, let's come in here, hop back into the deck box, inner case, and chamfer this again. Put this chamfer back in. And we did 2 distances last time. And let me just go 1 for now, because it may not be super critical. The depth here may not be super critical. And let's see what that looks like. So I'm going to rotate this guy up. And actually, let's throw this section analysis back on. And I'm just going to do this by eye for right now. Assuming I can click that. There we go. Is that clipping? That actually doesn't look like it's clipping, so should be good. Groovy? Yeah, that looks groovy to me. Alright, cool, easy. And the far corner, I'm just also looking up here at that far corner, and it looks like we're clearing that corner as well. Yep, alright, cool. So that gets everything back to where we were before we screwed everything up. So that is going to be where we end off with for today. Didn't get as much done as I wanted to get done, but I need to get going since it's after 5. So thank you all for watching, and do tune in next time, where we'll be putting in the hinged lid here, which will connect to the rotator, the spin top. And then after we get the spin top done, then we will fill out the dice chamber, which is over on this side, and whatever I decide to put over on this side in order to cover up the spin top. So that's the plan for next time. As always, have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.